Hi, this is Arun Bhatia, and welcome to another episode of TFR Newsroom. And today we have with us Moolchandani, CTO and co-founder of Accurics. First of all, welcome to the show.
Thank you so much.
Tell me a bit about the company and also the name. What is the story behind the name, and what is the story behind the company itself? That what problem you saw in the market at that point that you wanted to solve that you co-founded this company?
Sure. So first, the name Accurics. It represents accurate infrastructure as code security. Now, from the point of view of what do we do, right? So if you focus what's happening around us, at least at this moment, and not more than ever, all the organizations are embracing cloud infrastructure to build their applications. Especially in the COVID-19 situation, cloud is the go-to place for doing your technology and delivering your services. Now, when I say cloud infrastructure, I mean much more than just traditional network storage or compute. The current cloud infrastructure also includes technologies, such as serverless, containers, Kubernetes, and service mesh technologies. Now, these technologies are being provisioned more and more through code now. The time has gone now when folks were deploying these technologies manually on cloud. All these technologies are getting deployed through code, and that is the code which is called as infrastructure as code. Now, in order to install your operating systems or configure applications, you need to be able to do this infrastructure as code. A lot of organizations are adopting this new paradigm. This paradigm also has enabled organizations to adopt a strategy of infrastructure deployment, which is known as immutable infrastructure strategy, where the infrastructure actually is never modified after it has been deployed. In fact, if something needs to get changed, the change has to first happen in the code, and then of course the code has to go ahead and provision these new changes in the cloud. So then the question becomes that how do we secure this infrastructure as code when the entire infrastructure code is actually presenting a transient situation? So despite of organizations adopting a lot of cloud security tools, only 4% issues are actually being reported reported for these tools which are reporting the issues to be fixed. So this is because the fact that the resolution of tracing the issues back to the infrastructure code is not available in market today. So if you want to fix an issue that you have found in cloud, you actually have to be able to fix it in the infrastructure as code. And now there's no solution out there which faces or which solves this problem. So with all of these situations, we are witnessing a very high-profile cloud breaches today, one after the other. In fact, 30 billion records were exposed just in last 2 years because of the cloud misconfiguration. And that's where comes the Accurics. So at Accurics, what we believe is that the only way to secure immutable infrastructure is to adopt the paradigm of immutable security. And what that means is that organizations need to embed security earlier in the development lifecycle by continuously scanning their infrastructure as code for risks and fixing them even before the cloud infrastructure is provisioned. And that's when your ISC is going to become the single source of truth, right? So this is what Accurics does. So Accurics manages your infrastructure as code from security point of view. It assesses your infrastructure as code, presents you with risks that are present in that, and tells you if your cloud would have been born secure or not even before the cloud was built. So that's by and large what Accurics does.
And how much role does zero trust play in the immutable security landscape or paradigm?
Actually, one of the foundations of zero trust is immutability. So zero trust doesn't mean do not trust anybody. Zero trust means continuously trust and continuously verify. So trust but verify continuously at every occasion, at every milestone of your infrastructure deployment. So Immutability actually promotes a zero trust network. Immutability makes sure that changes are going in only from the single source of truth, and that's kind of becomes the foundation of your zero trust network. So let's say you are trying to build a zero trust network where you have multiple components. Each component has to have a trust but verify situation. That trust but verify situation is codified using infrastructure as code. Anybody goes and makes a change into infrastructure into the cloud directly without maintaining the right infrastructure as code will end up breaking the zero trust network.
If you look at security in general, for a long time, it has been kind of afterthought for developers. Nobody starts building their application with security in mind. They just focus on what value it brings to either the company or the customers. But things are changing, especially in the cloud space. We now have, things like, DevSecOps. So from your perspective, first of all, what has been the driver of this change where companies are looking at security more seriously? And number two is you did mention that there is a kind of increase in that kind of thing. So what kind of trend do you see, either in terms of projects which are focused on security, in terms of companies that are popping up? At the same time, a lot of consolidation is happening. If you take example of VMware, they have acquired a lot of security-focused companies in the last couple of months. So it's like kind of multifold question to better understand the changing security mindset within the cloud native world.
I think what the key term there is the cloud native technologies, as you just mentioned. Now, organizations who are more keen to adopt cloud native technologies, they have to be able to understand the foundations of cloud native technologies, which are actually more in openness and also are built using open standards. These open standards then are now allowing technologies like infrastructure as code, for example, Terraform, YAMLs, Hem charts. These are the technologies which are now enabling the developers to go ahead and codify their cloud native technology deployment strategies, which was not available many years ago. Now, with the advent of infrastructure as code, because most of the cloud deployment now is possible to codify, that's where a big opportunity has emerged for the security community to also codify security, which is a huge paradigm shift because previously the security tools were not able to match the scale and speed of DevOps. And that's where what was happening was, even though the tools would end up reporting security risks, the DevOps and the other stakeholders would not be able to actually take action upon them because the speed of DevOps is pretty agile, very high, right? Now, with the advent of infrastructure as code, a new situation has emerged where the security can catch up with the DevOps speed, because just in the way how you can now codify your deployments, you can codify your security as well. And that is what has brought the huge shift in the mindset. DevOps community is now ready to adopt security because now the security is being done in the DevOps way. So the term DevSecOps has existed since few years, but the foundational technologies were still not that mature to actually provide the DevOps teams these capabilities that they can use in their day-to-day life and in their day-to-day workflow without actually breaking their existing processes and without actually compromising their speed. And that's where I'm seeing a huge shift. New companies are emerging in the infrastructure as code space where people want to do security now from the left. The security has been shifting left, but with the advent of the automation that is available with the help of infrastructure as code, you can now also automate the security piece also on the left side and match the speed of DevOps. That is what has brought the big shift in the paradigm.
You also released your first state of DevSecOps research report. Talk a bit about the report. First of all, why you released the report. Second was what are some of the most interesting findings of the report?
Sure. So industry hasn't really, subtly and subconsciously, industry has been adopting infrastructure as code, which got popularized around 2013-14 timeframe. Many open source projects have kind of popped up since then, and a lot of adoption of infrastructure as code has happened, but it has happened in a layer of in such a layer where not much of attention has been given to it. So what we wanted to do was we wanted to first research and understand how many companies out there are actually using infrastructure as code first, and then what are they doing with respect to the security issues that are reported with respect to the infrastructure that is built using infrastructure as code. And while we wanted to throw sunlight on the state of DevSecOps, we also understood that DevSecOps has been shifting to left, but we wanted to see the impact of the previous efforts that have been put together with respect to moving DevSecOps to left. So very interesting outcomes that we discovered. We found that 96% of cloud issues that are reported during the production are actually never addressed. And when I say never addressed, means they are just left open. The reporting happens, but remediation and mitigations, they are not happening. Likewise, 24% of all configuration changes are today being made using infrastructure as code, and this is an ever-rising number, which is a significant adoption given that these technologies are so recent. And again, another very interesting factor we found was that the shift towards provisioning the cloud infrastructure through code offers organizations the opportunity to embed security earlier in the DevOps lifecycle, but there is a lack of holistic protection, which actually leaves the infrastructure more vulnerable, because now you are building infrastructure through infrastructure as code, which is automation. But if you don't do security early, then it becomes a very costly affair to do security later on. And fixing that also is a big challenge. And therefore, we found that in 90% of the cloud environments that we studied, we found that the security posture drifts are actually drifting away so much from the original baseline, which is actually set in the code. Your intent was written in the code, but your actual, which got built in the cloud, has drifted away so much over the period of time. So these drifts that are getting introduced because of the differences in the ISC and in the actual cloud is causing a lot of challenges. So these are some of the top outcomes that we had from our report.
I may get the number wrong, but I think you said like 95%, something like that, which are reported are never addressed. I have two questions. And number one is that, why do you think they are never addressed? Second is that when you look at security, there are reports. I'm not talking about bad configuration. I'm talking about CVs or vulnerability which are there in project. Most of them don't even get added to the national database as well, which also kind of shows that people are still not taking security as seriously as they should. So this is, once again, twofold question is one of why you think those issues are never addressed. Number three, in general, what is the perception that whenever there is secure CVs or any other security issues, projects, they release their patches, but if you look at Equifax example, the patches were never applied in actual production. Why?
So two answers for this question. First is that it's not that people are not taking security seriously. The intent is there. The community has grown. There's a lot of education within organizations now that are dedicated security teams. So security is being taken seriously. The challenge is that, as you gave the example for Equifax, the teams which actually manage your production environments, DevOps teams, their speed is very, very different from the speed at which the security moves. And the fundamental challenge there is that the DevOps teams have to meet certain SLAs, timelines, and the security tools require today different level of workflows. So because of this gap in the industry where the security workflows are totally different from the DevOps workflows, that is what creates the situation where the issues are left unremediated, or they are left open. In case of Equifax, they knew it. There's a struts vulnerability that they need to mitigate. They couldn't find the time. But time is just a notion given here to a process problem, which is that the mitigation technologies are not embedded into DevOps workflows. If that was the case, the DevOps will go ahead and actually adopt the mitigation strategies in a very seamless manner. And that's where organizations like Accurics come in, where we try and merge the processes that the current DevOps teams are following with the security overlay on it. And we are able to enable the DevOps teams to go ahead and address security issues with the help of features like remediation as code, where we actually are creating remediation in the code and providing that code to the developers in the developers workflow to go ahead and apply the remediations, fix the problems without the DevOps teams needing to change any kind of existing processes. So there's no process break. That allows us to maintain the speed of DevOps as well, and at the same time, close the security gaps as well. So that's the major challenge that industry has been facing.
Are there enough players in the space, like the demand and supply, at the same time awareness plus security itself is a very complicated, a lot of companies, they are in different phases of their either cloud journey or digital transformation journey. They also have a lot of things on-prem, they are multi-cloud, they are a hybrid cloud. So what makes it even more complicated when it comes to either provisioning or managing infrastructure through code? What is, you may have seen some patterns, some challenges that you just come across over and over again. What are those?
Right. Definitely doing security is difficult, especially in this polyglot world where we are living in, where we have, hybrid, multi-cloud, different stacks in your technology layer, especially in the cloud space. That makes it even more challenging. And security has different areas. Some areas are more difficult. Some areas have matured and have become commodity. But operationalizing those areas is also kind of a challenge where education is needed. At times, you require teams to have security knowledge, which is not possible for every team to possess, right? Especially the DevOps teams who have a lot of other things to take care of. They cannot be thinking security parallelly. They have to be able to do that. So that's where we need to enable these teams. So take, for example, doing threat modeling is a specialized job, which allows you to visualize your threats even before your, say, cloud environments are built, right? That's a specialized skill. But doing cyber hygiene, for example, identifying the misconfigurations and fixing them early in the life cycle, that's not too difficult. But where the difficulty is that current tooling doesn't really support some of these easy things also to blend into the delivery pipelines of DevOps teams. That's where the industry needs to work more, make the adoption of commodity security technologies easier for DevOps. Like, for example, as you mentioned previously in your question, vulnerability management. Vulnerability management now also needs to think about how they can amalgamate the processes into the DevOps pipeline in a way that it becomes easier for DevOps teams to kind of go ahead and do vulnerability mitigation. Likewise, misconfigurations. These are table stakes. These are low-hanging fruits. These can easily be operationalized in the DevOps pipeline. Of course, there is lack of tools today to be able to do those things in the right way. But some of the specialized security areas, for example, threat modeling or breach path simulations, those are the areas where then industry needs to work more, create more automation, more tooling, and make it more available to the teams who are not primary security teams. This way, we need to be able to enable DevOps teams. We also need to enable security teams to work at scale. So that's how the industry, I see, is going to move towards solving this problem where we have teams who actually do not have much of security capabilities, but on the other side, we have product security and CISO organizations who are struggling with the fact that how should they match the scale and speed of DevOps. That's where these emerging tools and emerging technologies such as ourselves is going to play a critical role.
Now, can you, since you were talking about tools, so I am curious, what kind of tools do you have? Can you talk about either your products or services that you offer to the community or the customers? And second, I always ask twofold question, is how much you leverage open source to build these tools and services?
Sure, absolutely. So we have primarily three different offerings. Number one is that we offer immutability drift management, where we are able to identify your drifts between infrastructure as code and your cloud environments, and also a cloud environment that you would have built previously versus your current cloud environment. That provides, we are able to identify whether these drifts are good or bad from security point of view. So we sell immutability drifts and immutability security risks as the first use case. Second area for us is to sell, what we sell is compliance as code or policy as code. So we basically assess policies like NIST policies, CIS benchmark, SOC 2. We assess all these policies right by looking into your infrastructure as code and tell you, even before your cloud is built, that how much compliant you are to certain policies. And we also have custom policy mechanisms available. Lastly, we have remediation as code, which allows us to provide automated remediations for all the issues that are identified using our platform. And we embed into developers' workflow and DevOps workflows seamlessly to operationalize the remediation pieces. As far as the open source technologies goes, all our offerings are mostly built on open source. One of the key open source technology that we use is OPA, Open Policy Agent Framework from CNCF. It's a CNCF-backed project. We use Rego as our choice of language for defining our policies. Again, open source allows us to bring more flexibility, engage with more developer community. Independent developers are able to develop the policies that we are checking. And we also have our own open source offering, TerraScan, which is available now to download. TerraScan is an open source version of our commercial offering, and it provides almost all the use cases and features that we have today in our commercial offerings.
Thank you so much for taking your time out and talking to me today. And as you said rightly, I look forward to talking to you again. Thank you.
Thank you so much.